Okay, this is 2009 paper, and this is question 13. Give you a moment to read it. Okay, time's up. Jason's satellite reaches its operational circle, blah, 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 and then begins mapping the Earth. So we know this is Jason's satellite, and it's out some really far distance. R equals 1.33 times 10 to the 7 meters. And here's all that other information. It's mass. Okay. Shell the direction of the force acting. You can know that. So, what is the force acting on Jason? We know he's moving in a circle. So, well, actually, that doesn't matter as much. We want to talk about all forces. If it was net forces, we'd be done, because that's a net force. We have to talk about any forces. If we're ignoring everything else, the only thing that's happening here is gravity, and gravity's pulling you inwards. He's moving this way. Moving this way. He has velocity, but nothing's pushing him that way. So that's it. That's our answer. What is the period of the orbit of Jason 2 satellite? So I want the period, which is t. And what do we have up here? We have mass and radius. So we have mass. We want period. We just need a way to convert them. And luckily there are formulas here. This is a gravitational field formula, so if we want a gravitational field we could get any of these. But they just equal each other. So I want period and I have mass, I just write that formula down. Gm1 on r squared equals 4 pi squared r on t squared. Or t squared equals 4 pi squared r cubed on gm. And this m1 is, I think of m1 as mass of the big thing. So we don't need that. Or maybe we need it later. Oh, so don't scribble it out. I'll just see if we need it later. We don't need it later, so that's okay. What is the period of orbit of Jason 2 satellite? So we need to just put these values in. 4 times pi squared times r cubed. So that's r cubed times 1.33 times 10 to the 7. That's all cubed. That's right. Yep, that's right. On gm1. So it pays to do a little bit of calculation before. That's G, and that's M. So it pays to do a little bit of calculation before you go into everything. I'm going to bring it up here to make it easier for you to see. So you can split the cubes. This is 10 to the 7 cubed. And when you have something cubed, because you're going to be using cubes a lot in gravity, just multiply them together. Okay? If I tried to do this on a calculator, I'd get it all wrong. That's why I do it like this. And then I put these 10s together. So 24 minus 11 is 10 to the 13. And now because this is below, you have to subtract it. Now try and remember that. Subtract it. So I can cancel all of these out, and we're left with 8. So now all I need to do is put this into the calculator. Much easier than putting all those giant cubes and different things like that. Pi, 4 pi squared times 1.33 to the power of 3 divided by 6.67 divided by 5.98. And that gives us 2.3 times 10 to the 8. That's our time. Oh wait, that equals t squared. That is not right. So yeah, I like to take it in steps because otherwise I make mistakes. Sometimes I make mistakes anyway. Can't avoid them. Square root of our answer times 10 to the power of 8 gives us 15259. 15259 seconds. Okay, great. And that's it.